Hey, everybody. Thank you for coming. This talk, I'm going to try to share some of the lessons that we learned from writing 300,000 lines of infrastructure code at Gruntwork. First lesson is I actually originally called this talk 10 lessons learned. It's a really bad idea before you write the talk, because then you write it and it's like 3 hours long. You're like, ugh, OK. So it's going to be 5 lessons, which hopefully will be enough for now. And the goal is, as you start writing infrastructure code, as you start using some of these tools, hopefully you'll be able to avoid some of the mistakes, some of the silly little things that we did. But before I get into that, I want to set the context a little bit. And I want to give you a little bit of a confession. So here's the truth. I've been doing this stuff for a while, working on DevOps and infrastructure. And the reality is DevOps is still very much in the Stone Ages. And I don't say that to be mean, it's just we're new to this, right? We've only been doing DevOps, we've only been figuring out SRE practices, how to do software delivery for a little bit of time. And this is a little scary, though, because we're being asked to build infrastructure that looks like this, right? We're supposed to build these incredible, modern, powerful systems, but it feels like we're trying to do that with tools that look like that, right? You got your like duct tape and a little bit of bubble gum and like, good luck. Of course, if you read the headlines, it sounds like everything is so cutting edge, right? You open any web browser, you look at any blog post, and you hear nothing but Kubernetes and Docker and serverless and microservices and buzzword this and buzzword that. And it sounds really cool. But it doesn't feel like that to me. I don't know about the rest of you, but when I'm actually doing this work, when I'm actually working on infrastructure, it doesn't feel cutting edge. It feels a little more like that, right? I'm like trying to heat up like a slice of pizza on an iron, like I don't know what the hell is going on here, but this is DevOps, right? This is my new hashtag. This is DevOps, okay? It doesn't feel cutting edge. It feels like this, like, I mean, I don't know. I guess this works, but like, why? Why are we doing it this way? This is crazy, right? And like, nothing fits together right. Like, I don't know. Sure, go, but what? Come on, man. And like, this is probably an accurate depiction of like the typical CI/CD pipeline at most companies, right? Like this is what it feels like. And we don't talk about that enough, okay? We don't admit to ourselves often enough. We like to talk about all the cool stuff. We don't talk enough about the fact that this stuff is hard. Building production-grade infrastructure is hard. It's really hard. It can actually be really stressful. I think, generally speaking, it's probably not crazy to say that people in the DevOps industry tend to be a little more stressed out than other parts of software engineering. It's also really time-consuming. And this aspect is always hidden. Because you only see the end result, right? You read a blog post, and at the end of the blog post, it's like, and ta-da, Kubernetes. And you're like, wow, that sounds great. But you have no idea what time or work went into it. And so I want to share with you some of the rough numbers we've found from working with a lot of companies, doing this stuff a lot of times. And these numbers are probably best-case scenarios, to be honest with you. So hopefully you can read that. This is what it's going to take to write infrastructure code that you can actually use in production. And I'll come back to what I really mean by production-grade infrastructure a little later in the talk. But here's the basic numbers. If you're using a managed service, something that AWS or Azure or GCP is managing for you, you can probably get up and running in a production capacity in a couple weeks with that, 1 to 2 weeks, because the managed service provider is doing all the hard work. But if you're going to spin up your own app, and it's some sort of distributed system, but it's stateless, it's not writing to disk or anything that you care about on disk, like a Node.js app, some sort of front-end applications, that's going to be double, 2 to 4 weeks. You want to build a distributed system that's stateful, something that writes to disk and you don't want to lose that data, something like setting up your own Elasticsearch cluster, your own Kafka cluster, MongoDB. Now we're talking 2 to 4 months. We're going to jump an order of magnitude here. And that's for one distributed data system, right? If you have multiple, it's 2 to 4 months for each one, and then the interactions between them actually make things even more complicated. And finally, if you want to put together your entire architecture from scratch, we're talking a 6 to 24-month project. 6 months is probably for a tiny little startup. 24 months is more realistic for most larger companies. For some, it'll take far, far longer. So when you read those blog posts that are celebrating these incredible milestones, like, put a little checkbox in your head that, like, these are the timeframes we're talking about. These are the best-case scenarios for things that are understood. So the good news is a lot of this stuff is getting better. So I don't want to be a downer, or there are problems, but they are getting better. And one trend that I really like, I think something that's very positive, is we're able to manage more and more of what we do as code. And we're seeing this kind of across the stack, right? We're going from manually provisioning hardware to infrastructure as code. We're going from manually configuring our servers to using configuration management tools and using code. Going from manual application config to configuration files. Everything is moving to code. And there's a lot of benefits to code. I mean, this is why I'm excited about it. Hopefully, if you're at this conference, you don't need to be convinced too much of the benefits of code, but it's everything from being able to automate things instead of having your poor SRE do everything by hand 300 times. You get to store the state of all of your infrastructure in version control. You get to review every change. You get to test every change. The code is documentation. So it's not just locked in somebody's head. And you get reuse. So you can use code written by other people as well. So at Gruntwork, what we've done is we've kind of run with this idea of infrastructure as code. And we built a library of reusable code. Most of it is written in Terraform, Go, Bash. I'll come back to the tools we use a little bit later on. And we have these off-the-shelf solutions that give you production-grade infrastructure for a whole bunch of different technologies. And we have a whole lot of customers using this stuff in production. And so what that really enables is you go from these time frames of weeks and months to do these things from scratch, to down to about a day, mostly because the Gruntwork team has invested that time on your behalf. That's the benefit of code. You get to reuse us kind of toiling away for months and years on this stuff. And we've been working on it for a while, right? So we've been working on this library for more than 3 years. It's well over 300,000 lines of code. So it's a pretty sizable amount of infrastructure code. And so based on all the ways we got this wrong, hopefully I can help teach you all some pretty useful lessons. There we go. So I'm Yevgeny Brickman, go by the nickname Jim. I'm one of the co-founders of Gruntwork. Author of a couple books, Terraform Up and Running and Hello Startup. These books talk quite a bit about these DevOps concepts. And so these are the 5 lessons that I'm going to share with you today. First, I'm going to go through a checklist of what it really means for infrastructure to be ready for production. And then I'll talk about the tools that we use and some of the lessons we learned around that. I'll talk about how to build modules in a way that they're actually useful. I'll talk about how to test your infrastructure code. It's a very rare topic. And then I'll talk about how to release this stuff into the wild. So we'll start with a checklist. And when I tell people about these numbers, right, when I show somebody that's relatively new that it's going to take this long, I get a lot of skeptical faces, right? Usually they look something like that. It's like, come on, really? 6 to 24 months? I read a blog post. I read this thing. I'll get this done in a couple days. No, you won't. It's going to take a long time. You're just not going to. And so why? So I get a lot of incredulity, and people are asking, why? Why does it take this long? And so I think there's 2 really main reasons. They're very similar, but they have slightly different flavors to them. So the first one is something called yak shaving. Who here is familiar with the term yak shaving? Wow, it's less than half. OK, so for the rest of you, you're welcome. This is going to be a term you're going to use probably every day of your life from now on, so pay attention. So here's what yak shaving is. Yak shaving is this like seemingly endless list of tasks you have to do before you can work on the thing you actually wanted to do that day. So the best definition I've seen of this is from Seth Godin's blog, and he gives an example like this. So you come home one day, and you want to wax your car. So you go out to your backyard, you grab the hose, and, oh, crap, my hose is broken. No problem. I'll go to Home Depot. I'll get a new hose. You get in your car. You're just about to go. And then you remember, to get to Home Depot, I need to go through a bunch of toll booths. I need an Easy Pass. No problem. I'll go to the neighbor's house, grab his Easy Pass. Then you remember, he's not going to lend me his Easy Pass because I borrowed his pillows. I got to return the pillows first. So you go rooting through your house. You find the pillows. And you realize that all the yak hair has fallen out of the pillows while you were borrowing them. And so the next thing you know, there you are, sitting in a zoo, shaving a yak, just so you can wax your car. So that's yak shaving. And if you do DevOps, you know what I'm talking about, right? You want to go deploy a service over here, and then there's some TLS thingy you have to do. And while you're working on that, you uncover this other weird bug. And then while working on that, you broke something in production. And you're miles away from what you originally wanted to do. And this happens all the time. DevOps just seems to consist of 1,000 tiny little interconnected systems. And they all break, and everything you do, you end up yak shaving. And the weirdest part is, at the end of the project, you're like, what the hell did I just spend the last 3 months doing? I feel like this should have been 5 minutes, but it's maddening. So yak shaving is one big reason. Second reason is there is genuinely a long checklist of things you have to do to build infrastructure for production. So I'm going to share our checklist with you. These are the things we look for when we're building infrastructure that we want to use in production. And what I mean by that is this is the kind of infrastructure you would bet your company on, right? If you're going to deploy a database, you don't want it to lose your data, because if you do, that could be a company-ending event. So this is what I'm talking about when I say production grade. So here's the checklist. Actually, this is the beginning of the checklist. And the first part of it, most people are familiar with it. These are the parts that just about everybody can guess, right? You have to have a way to install your software. Duh. You have to configure it, port numbers, users, folders, et cetera. You have to provision some hardware to run your software. And you have to then deploy it, potentially update it over time. So everybody knows this. This part is easy, but that's part 1 of 4. So this is what you get. This is what most people forget. So here's part 2. Security is usually an afterthought. Things like, how do I encrypt things in transit, right? That whole TLS thing. How do I encrypt things on disk? Authorization, authentication, secrets management. How about monitoring, right? If you want to deploy something to production, you probably want to know what's going on with that thing. Have some sort of metrics and alerts. You want logging. You want to rotate the logs on disk so you don't run out of disk space. You want to aggregate them somewhere so you can search them. Backup and restore. Again, if you're running a distributed data system, or any data system, you probably want to know that if it crashes, you're not going to lose all your data and go out of business. Here's a few more items that tend to get forgotten. How about the networking setup, right? All your subnets, all your route tables, static, dynamic IPs. How about SSH access, VPN access? You have to think through these things. These are not optional. You need these for almost every piece of infrastructure. Then you got to think about high availability. What happens if a server crashes? What about a whole data center? Scalability. What happens when traffic goes up and down? How do you react to that? And performance, right? There's a whole field of things that you have to do. If you're deploying a JVM app, you have to think about GC settings for just about anything. You have to think about memory, CPU. You might have to do load testing. That could be months of work just by itself. And then these ones, almost nobody gets to page 4, right? That's part 4. People usually have dropped out long before this, right? Cost optimization. How do you make this thing affordable? Documentation. If you ask people where are the docs for your infrastructure code, they're like, what? And tests. Like, it's rare to see tests for infrastructure code. But this is the checklist, OK? These 4 pages are what you want to use. When you're building infrastructure, this is what you need to do for just about every piece. Now, not every single piece of infrastructure needs absolutely every single item here, but you want to at least make the conscious decision that we're going to build these aspects and not build some others. You don't want that to happen by accident. You don't want to find out 6 months later, oh crap, I forgot about backup and restore, and you usually learn that the hard way. So, key takeaway, next time you go to build a piece of infrastructure, use this checklist. I'll be sharing this slide deck. Actually, it's already on SlideShare, but I'll tweet out the link and I'll post it in the HashiCorp hashtag. We also have on the Gruntwork website, there's a checklist for your entire architecture. So not just one piece of infrastructure, but everything that you're going to do. And so you can find that on our website, gruntwork.io/DevOps checklist. It's also in the footer, so it might just be easier just to go to gruntwork.io and click it. OK, that's the checklist. Second thing that's worth thinking about are the tools. So you know what you need to do. What are the tools you're going to use to actually implement that checklist? So when we're thinking about the tools that we want to use, these are usually the principles that we're following. We want things that let us, of course, define our infrastructure as code. We want them to be open source and have a large community. We don't want to have to build everything ourselves. Hopefully, they're cloud agnostic and work across many different providers. We want tools that have very strong support for code reuse and composition, and that'll come up in the next section. We don't want to run extra infrastructure, right? I want to deploy my infrastructure, not deploy infrastructure to deploy my infrastructure. I want to keep it simple. And we like immutable infrastructure practices, so when possible, we like to use tools that make that easier. So the tool set that we're using now, and bear in mind, this is not some like religious debate. This is just what we're using today, because for practical reasons it makes sense, is as follows. So our basic layer, the underlying infrastructure, we use Terraform. So that's going to lay out all of the basic networking configuration, load balancers, databases, and of course, all of the servers that we're going to run our apps on. So those servers, we need to tell them what software to run. So on top of that, we're going to use Packer to build our virtual machine images. Some of those VMs will have things like Kafka installed or Redis. Some of those VMs are going to have Kubernetes agents or ECS agents, and so they're going to form a Docker cluster. And in that Docker cluster, we're going to be able to run Docker containers. And generally speaking, the way we work as of today is we use the Docker containers for stateless applications, and stateful applications we run outside of Docker usually has their own VMs. That's starting to change. I think Docker, Kubernetes are becoming a little more mature in that space, but I would still be terrified to run like MySQL on top of Kubernetes. That just wouldn't do it. Final piece of technology that we're using here is under the hood, all of this stuff. This is our duct tape. This is our paper clip and our twist tie. It's a combination of scripts like Bash and Python. We use them, for example, to define the Docker containers. We use them as glue code. We also use Go. Anytime we need a standalone binary that's going to work on any operating system, we'll write that application in Go. So those are the main tools, basically Docker, Packer, Terraform, and some mix of general purpose programming languages to kind of hold everything together. So here's an important note. These are the tools we've picked. They fit our use cases. You're welcome to use them. You might find other tools are a better fit for your use cases. But the key insight here is not you should use those tools. That's not really what I'm trying to teach you here. The key insight here is that while tools are useful, they aren't enough. So you can use whatever tools you want in the world. It could be the most incredible piece of technology out there. But if you don't change the behavior of your team, it's not actually going to help you very much. And here's why. So if you think about it, before you start using infrastructure as code, the way that your team is used to working is if you need to make a change, you do it directly. You SSH to the server, and you run some command. You connect to the database, and you run some query. And what you're saying now is, I want to change this, so now there's this level of indirection, this layer of indirection. You need to go change some code. There might be code reviews. There might be some tests. Then you got to run a tool, and that thing is going to apply the actual change. And that's great. There's a lot of good reasons to do that, but these pieces in the middle, they take time to learn and understand and use properly. And if you don't invest that time, you're going to have the following scenario. Something's going to break, and your ops person is going to have two choices. They can either do what they already know how to do, make a change directly, 5 minutes, or they can spend 2 weeks learning that stuff. It's a rational person. Every time they're going to choose to make the change manually. But if they do that, now your code, whatever tool you chose, but that code is not going to accurately reflect reality. And so the next time somebody tries to use the code, they're going to get an error. And then they're not going to trust that code, right? I tried to run Terraform. I got a weirdo error. Never mind. They're going to go and make a change manually. So then the next person is going to be even more screwed, and the next person, and within a few weeks, that incredible tool that you spent all that time working on is basically useless because people are changing things by hand. So the problem with that, of course, is that doesn't scale. Making changes manually, if you have a few people, few pieces of infrastructure, fine. But as your infrastructure grows, as your team grows, this does not grow with it very nicely, whereas this does. And so the key takeaway here is you need to change behavior. If you're going to be adopting Terraform, Packer, Docker, any of these tools, you have to give people the time to learn these things, the resources to learn these things, do training, go to conferences like this, go read blog posts. And you have to make sure that they're bought into it, right? The last thing you want to do is have an ops person who just like, I hate this Terraform thing. I'm never going to use it. Like, that's not going to work. Terraform's not going to help you. So you got to change behavior. That's really the takeaway here. OK, third item is how do you build modules? Something that we found, something that we learned the hard way, is even if you pick a good set of tools, even if you change behavior, and you just sit somebody down who hasn't done this before and tell them, OK, go build your infrastructure, they tend to shove all of it into a single file or a single set of files that's all going to get deployed together. So the dev environment, test environment, stage environment, everything is just shoved into one super module, essentially. And what you'll find out very quickly and very painfully is this has a huge number of downsides. For one thing, it's just going to be slower. We've had customers where running Terraform plan would take 5 minutes just to get the plan output, because there's like 3,000 resources, and you have to like make API calls and fetch data about them. But even if that wasn't as big of an issue, that plan output is impossible to understand, right? If you run Terraform plan and you get 900 lines of result, no one's going to read that. You're just going to say, yeah, I hope it's good, fine, apply, yes. And you're not going to catch that little line in the middle that's red that says, by the way, I'm deleting your database. You're not going to see that if you have a gigantic module. It's also harder to test. So we'll talk about testing a little later, but the bigger the module is, the harder it is to test it. It's harder to reuse the code, because if everything is in one giant super module, it's hard to reuse parts of it. Another one that a lot of people miss is if everything is in one super module, then to run anything, you need permissions and access for everything. Basically, every user has to be an admin because all of your infrastructure is in there. And that's terrible from a security perspective. And finally, your concurrency is limited basically to one. So only one person at a time can change anything in any environment ever. So that's obviously a problem. And of course, the biggest issue with all of this is if you make a mistake anywhere in this code, you could break everything. You might be editing your staging environment, you make a silly typo, and you're not paying attention, and because it's all shoved into one set of code, you blow away production. This happens. This isn't hypothetical. This happens on a regular basis. So here's what I'm going to claim is large modules in infrastructure code world are harmful. They're an anti-pattern. They're a very bad idea. So what you really want is you want isolation. You want the different parts of your environment to be separated from each other at the code level and obviously in the infrastructure level. I mean, that's why you have separate environments in the first place, right? You want stage to be isolated from prod. You actually also want isolation between different types of infrastructure. So for example, your VPC is something you'll probably deploy once, and you're probably not going to touch it again for a year or a long time. Whereas your front-end app, you might be deploying that 10 times a day. If they're in the same set of code, then 10 times a day, you're putting your entire VPC at risk of just some silly typo, some silly wrong command, for no reason whatsoever. There's absolutely no reason to do that. So you kind of want to group your infrastructure by risk level, by how often it gets deployed. So the way you do that is you take your architecture, and it can be arbitrarily complex. You can have your VPCs, you can have your servers, your databases, load balancers, et cetera. And you're not going to define it out of one gigantic supermodule. You're going to define it out of a bunch of tiny little individual standalone modules. This pattern is the only one we've seen that works well, especially at scale, especially as your infrastructure gets more complicated. It's building it out of these little tiny building blocks. So what that's going to look like in terms of code is you'll start with your environments as the top level items, so dev, stage, prod, and they're all separate from each other. Within each environment, you'll have the different types of infrastructure. So maybe the VPC is separate from your database, is separate from your front-end application. And of course, you don't have to copy and paste between all of these. The actual code itself can be implemented in these small, reusable modules. And even the modules themselves can be built out of still smaller pieces, right? Kind of like modules all the way down. And there's a lot of advantages to doing this. Basically, it's the opposite of all the problems I talked about. Things will run faster. You can limit permissions based on just what you need for that one particular module. If you break something, the damage you do is limited, et cetera. So here's a quick example that I'll browse through. In the Terraform registry, we have a module to run Vault, which is a reasonably complicated distributed system. So this is some open source code. And if you take a look at that module, there are 3 key folders. This is how we organize the code for even one piece of infrastructure. And so those 3 folders are modules, examples, and tests. So I'll actually show you in IntelliJ itself. So here we have Vault. This is the modules folder. That font might be a little small. But essentially in here we have a few things, and I'll switch back to the slide deck since the font is not super readable. We have, for example, Vault Cluster is a separate submodule. So you notice, even though it's just Vault, it still consists of a whole bunch of different little submodules. Vault Cluster is Terraform code to deploy an auto-scaling group, a launch configuration, security group, whatever you need to run a cluster of Vault servers. Separate from that, we have other modules, such as Vault ELB. This is a Terraform code to deploy a load balancer. Security group rules are separate. Install Vault isn't Terraform code. That's a bash script. You can see it takes in what version of Vault to install. If you're using Vault Enterprise, the path to where the binary is. We have Run Vault in here. That's a script that will start Vault on boot. And here it'll configure TLS, port numbers, et cetera. So why do we have all of these tiny little submodules in that code base? The reason for that is it gives you a lot of power. You're going to be able to combine and compose those pieces in many different ways. If everything was in one gigantic module, it either works for your use case or it doesn't. And this isn't some hypothetical thing where you just want to support every possible use case out there. It turns out that you're going to want to run your own infrastructure in different ways in different environments. For example, in production, you might want to run Vault across 3 separate nodes. Vault, usually you run it with console. You might want to run console on 3 separate nodes. But in a pre-prod environment, you might want to co-locate all of those on maybe one server or just one auto-scaling group. And so you need to write your code in a way that you can do that. And the best way to do that is to break it up into these tiny little modules. And so just to recap, these are actually patterns. You might want to commit them to memory or use the slide deck later when you're building your own modules, because they come up again and again and again. Almost every piece of infrastructure has a similar structure. You have the modules folder. There's some sort of install script. Basically, you need to install the module, as you can remember from the checklist. There's a run script. This is what's going to configure it during boot. There's going to be some sort of Terraform code to provision the infrastructure for that module. And there's also going to be a bunch of these reusable components that you might want to share. So security group rules are a separate module, because I might want to use it with my Vault cluster. But if I'm running Vault co-located with console, I might want to attach the same security group rules to my console cluster instead. So these little pieces are very, very important. And each of them exposes a bunch of input variables and output variables so that you can wire them all together in a bunch of different ways. And so you can have one configuration of Vault that's set up like this, or using the same set of code, you can configure it differently with a different load balancer, a different way to install it, configure it. You have that flexibility and power, and you're going to use it yourself, let alone what happens as the infrastructure changes over time. There's an examples folder. And that's going to show you examples of different ways to combine and compose those little submodules. Now, we build that in part as documentation. It's executable documentation. But it turns out it's more than that. So some of these examples are Terraform code. Some could be a Packer template, et cetera. But where the examples become really powerful is with testing. And so in the next section, I'll talk about testing. But the key thing to remember here is when we're doing testing, what we're testing is usually those examples. We're usually deploying those actual examples as the way to validate that these modules work. So the examples are really, really, really useful. So key takeaway, build your infrastructure out of these small composable pieces. If you see a gigantic module, you should react to it a lot like you would if you were using Java or Python or any general purpose language, and you saw a single function that was 10,000 lines long, right? We all know that's an anti-pattern. You don't write 10,000 line long functions. It's the same in infrastructure code. You should not have 10,000 line long infrastructure modules. They should be built out of these little pieces. OK, how do we test this stuff? Something that we found, again, the hard way, and something that you're going to find as you're starting with this journey is that infrastructure code rots very, very quickly. Pretty much everything we're using is changing all the time, right? Terraform 12 is about to come out. That's a massive change to the whole language. Docker is changing. Packer, Kubernetes, AWS, GCP, these are all moving targets. None of them stand still. And so your code, even if it works today, might not tomorrow. And this happens really, really quickly, much faster, I think, than a lot of other programming languages. And so really the best way to put it is not that it rots very quickly, but I think this is the general law. Infrastructure code that does not have automated tests is broken. And I don't mean like it's going to be broken in the future. I mean it's probably broken right now. Something we found out the hard way is even if you test this thing manually, you're building a module to run Vault, you deploy it, it runs, you can store secrets, you can read secrets. As best as you can tell manually, it's working. When you take the time to write the automated test, every single time we have caught non-trivial bugs in our code. Every single time, almost without exception. So if you don't have tests on your infrastructure code, it's broken. Just be aware of that. Now, we know how to test code in general purpose languages, Bash, Go, et cetera. We can write unit tests that mock the outside world, and we can run those tests on localhost. For infrastructure code, this is a little harder. There's no localhost for Terraform, right? If I have Terraform code to deploy an AWS VPC, I can't deploy that onto my own laptop. There's also no real unit testing. I can't, for the most part, mock out the outside world, because the only thing Terraform does is talk to the outside world. So really, all of your Terraform testing is actually going to be integration tests. And the test strategy looked like this. You're going to deploy the infrastructure for real. Remember those examples that we saw earlier in the modules? You're going to deploy those examples for real. So if you're building infrastructure for AWS, you're going to deploy it into a real AWS account. You're then going to validate that it works. Now, how that works obviously depends on your use case. For Vault, our automated tests actually initialize the cluster, they unseal the cluster, they store some data, they read some data, and then at the end, you're going to undeploy that infrastructure. So it's not very sexy, but this is how you test infrastructure code. And so to make that a little easier, we've open sourced a tool called Terratest. I did a talk here last year. It was not open source then, so I'm happy to announce that now it is available as an open source library. And it allows you to write your tests in Go. And it gives you a lot of utilities that make this style of testing easier. And the philosophy here is basically, if you're trying to figure out how do I test this module using Terratest, all you really need to think about is how would I have tested it manually? Because that's all we're doing. We're just automating whatever it is we would have done by hand. So here's a typical test structure that you would use with Terratest. So you can see at the top, what we're testing here is one of those examples in the Vault repo. And so we tell Terraform, OK, this is where the example code lives. At the start of the test, we're going to run Terraform init and apply to deploy that example into a real AWS account. We're then going to validate that this thing is working. Now, what does that do? That, of course, is very specific to whatever you're testing. But Terratest is a whole suite of utilities to make that piece easier as well. So there's libraries for looking up IP addresses of EC2 instances. There's libraries for making HTTP calls, checking the response code and body, and doing it in a retry loop, because you'll find that there's a lot of asynchronous and eventually consistent systems here. There's a lot of code that uses this SSH helper to basically SSH to a server and execute a command and give you back the standard out and standard error. And so there's all these utilities built in for validating that your code actually works. And then at the end of the test, that's what that defer word means. It means at the very end, we're going to run Terraform destroy to clean up after ourselves. And so these are all Terratest helpers. And it's not going to make the test easy to write, but a heck of a lot easier than doing it from scratch. And Terratest these days supports AWS, supports GCP, Oracle Cloud. There was a talk today about using it with Azure. So you should be able to use it for a whole lot of use cases. One important note is that when you're running these tests, we're going to be spinning up a lot of infrastructure and tearing it down all the time. So 2 important things to note about that. The first one, you want to run your tests in a completely isolated sandbox account. Don't run them in prod. I hope that's obvious. But I wouldn't even use my staging or dev account. I would actually create a completely separate place to run these tests where you don't have to worry what happens if I accidentally delete the wrong thing or create the wrong thing. Second tip is occasionally the tests don't clean up after themselves very well. The test might crash. You might lose internet connectivity. So you don't want to leave a whole bunch of resources around. And so we built a tool called Cloud Nuke. As the name implies, it's quite destructive. Don't run it in prod. But in your isolated sandbox account, you can use this to clean up resources older than a day or older than a week and basically not lose lots of money. OK, one final thing to chat about with testing is this test pyramid. Usually, you're going to have a lot of unit tests, smaller number of integration tests, smaller number of end-to-end tests. And the reason for that is, as you go up the pyramid, it takes longer to write those tests, they're more brittle, and they run slower. And so you want to catch as many errors at the bottom of the pyramid as you can. So with infrastructure code, similar idea. The bottom of the pyramid, that's going to be those individual submodules. You want to have small little submodules that you can test and be confident that they work as you put them together. Then integration test is combining a few submodules. End-to-end test is your entire stack. You're not going to have too many of those. And the reason for that is they're really slow. So the unit tests for those individual submodules, they're not fast, but it's as fast as you're going to get. And then it gets slower and slower as you go up the stack. Check out Terratest docs. We have a lot of best practices about how to speed up testing, so make sure to read that. So add tests. I'm almost out of time, so final section is releases. This one's really quick. I'm going to put together the whole talk for all of you. So here's how you're going to build your infrastructure from now on. 1, use the checklist. Make sure you're building the right thing. 2, go write code. Don't do this stuff by hand. Go write code. 3, write automated tests with Terratest. 4, do a code review. Make sure your code's actually working. Have your team members take a look. 5, release a new version of your code. What that really means is add a git tag. And now you can take that code, this versioned artifact, and you can deploy it to QA. And if it works well, then you can take the exact same code, because the artifact's immutable, deploy it to staging, and if it works well, finally to prod. And so here's the key takeaway for this talk. We're going to go from that to that. You know, we go from pizza on an iron to tested code that's been through a checklist, a code review. It's versioned, and we're rolling it out from environment to environment. It's not easy. It will take a long time, but it is helpful. That's it. Thank you, everybody.